Hello everyone, and welcome back to Vintage Machine Shed. In today's video, we're going to be machining this manifold flat again, and then we're going to be machining the area on the head flat again to help it seal against any exhaust leaks. Please subscribe and give a thumbs up. Looking at the manifold here, you can see there's two ports that are for the intake, and the remaining four are for the exhaust. Now the manifolds still have their gaskets on, or part of the gaskets on. What it is there's a metal keeper that goes over top, and actually there's a fabric gasket. This one kind of came off already. I'll show you a little bit here or over here. Yeah, here's a good example. That goes down, and the metal piece goes over top. So I can't really see the condition too well at this point without really scraping these down. So after scraping the gasket off the manifold and just running a flat file over them a little bit, if it shows up on camera, you can kind of see the shiny spots here. Probably would seal okay around the perimeter of that. This is the exhaust port, probably the worst looking one. But I think it is still worthwhile to set it up in the mill and try and machine that true and flat again. Machining the manifold presents a little bit of a complication. If you were to flip this over, there's really no flat spot to set it on the mill. So what I'm considering doing is where the carburetor bolts here, of course the gasket's still on. I'll peel that off. That should be at a right angle to where the exhaust and intake ports come out. So I may push this up against an angle plate, and then there are various little standoff tabs here. I believe that's something for the casting process. Up here too at another level. I may set them on the exhaust and intake ports, kind of the way it's sitting now, and then machine these little tabs and possibly flip it back over then and try and reference off these tabs, and then have this backed up against an angle plate. Here's the setup I have for machining the manifold. I originally set the manifold on the ports on the granite surface plate, and it had a little bit of a rock in, so I knew it wasn't perfectly flat, and that certainly could be expected. The manifold is made up, this outer area around here goes to the exhaust ports coming down here. Then this area here is linked together right here. And if you see over here, it is separated from the intake side to the exhaust, but yet the stud coming out of the head clamps down there. So what we need to try and do is I'm going to machine these tabs here, and then step down to here and try and have an equal, or I don't know, come up with a number between here and here, and I'm not sure how that will end up yet, and possibly create a spacer of some sort so I can rest off on here and then rest off on these other tabs, flipping it over, and kind of be careful how it's clamped. Probably have to clamp in this area, I'm not sure yet, and we don't want to clamp too hard or it's going to distort. We ended up machining these tabs here. This one just barely touched off here. It hit a little heavier out on these sides and what I would have liked to seen, but we didn't go through. Then on the intake portion of things, it hit here and here. Here, I cut into here just a little bit. I decided it was going to maybe take off too much and didn't think that was really necessary. Here it did not touch off, and I don't want to go any deeper Right now we have a nice even 1/2 inch from here to here, which will make it easier for us setting up when we flip it over. Now the manifold is set up on blocks. On the tabs that we machined off, I have 1-inch blocks out on the exhaust manifold side of it, and then on the intake manifold part of it, we have 1-inch blocks plus 1/2 inch spacers. So it's sitting on here quite nicely. I have a boring head we're going to use in the milling machine. We're going to use it as a fly cutter. There's this horizontal rod you can stick through the side of the boring head, and once that's installed, I have a carbide cutter we're going to install horizontally into that vertical bar, and that will be our fly cutter. And we're going to be cutting it in the Wells Index milling machine. I just ran a pass across the manifold. You can see our cutter set up. I had put red dye on all the port areas here and actually set up the cutter off this one, set it at 0. You can see it actually hit every port with the exception, well, it did hit this one very lightly. Maybe it's a little hard to see in the camera, but it did lightly dust off our red, so we were hitting really even on all of the ports. I'm just going to take another real light cut, maybe about 3/1000ths, run it by and see what happens. So after touching off on the high spot, I lowered it 3/1000ths, and much of it did clean up. The exhaust port here, you can see the lighter areas where it did clean up, and then not so much on the outside. It's kind of expected. This one cleaned up well. This one here, we just got a little bit of a touch with the cutter here. The next one cleaned up well. The next one cleaned up well. This one did about 80% on the very outside. You can see it did not. When we machined the head on this mating surface, we did have that on the outsides of these ports as well. So it is probably a good idea that we did this, although the manifold has less wear than what the head did for some reason. I would have thought it would have been just the opposite, but we should have some good results when we're done. I'm going to take now another pass of 3/1000ths and see if that's enough to clean it up. Well, I thought that would probably be our last pass. So we've taken off 9/1000ths so far. They're all cleaning up, and actually it would be fine the way it is. You can see just a little bit of red left in there, although the sealing surface, it would be fine. It's sealed off. And on the very outside one here too, again, you can see where it's shiny. It would seal off okay, but we're going to go just a little more for good measure. Okay, so let's remove it from the milling machine now. We're going to set it up on the flat surface plate, and just to see if it actually is laying flat and see if there's any rock to it. So we're getting it set on the surface plate now. I'm just going to slide it around a little bit and rock it back and forth. It seems to be sitting very flat, so I would call this a good success. And finally, we're going to machine the mating surface to the manifold on the head. So before I decided to clean this head up further, I looked closer at the ports coming out of the side of the head where the intake and exhaust manifolds mount. It's a one-piece manifold, but the exhaust ports come out in 4 locations, and then the intake come out into just 2 locations. So wherever the exhaust ports are, at least on the outer ones here, I don't know if the camera will focus up on it. It doesn't show very well on camera, but they're a little bit pitted around the outer diameters. And while they would probably seal okay with the new seals in there, I decided just to take a skim cut with a milling machine. So we have the head mounted on the milling machine. I have a dial indicator and a magnetic base strapped to the horizontal area of the head on the mill. And I indicated in the head, a little hard to see here, but I indicated off the existing flange area where the manifold mounts, mainly off of the intake port sides, as they were the smoothest. So the head is now parallel to the table and the x-axis travel. So I put some red dye onto the area we're about to machine, just to make it easier visually to see what's going to clean up. I had to use a different boring head in the horizontal spindle, and the cutter I'm using is not ideal for it, but I think it will work. So after a very light cut, you can see the exhaust manifold area has barely touched anything, and on the intake side of things, you can see it kind of cleaned up part of it. We're going to move the cutter in a few more thousandths and take another pass. So after taking another 3 thousandths off, you can see some of the exhaust ones, at least the one down on this far end here, is cleaned up better. Both the intake ports have cleaned up nicely. The center exhaust ports a little bit, one not so much. This far end one here, really not at all yet. So I'm going to take another 3 thousandths off, see what it looks like. So here's another 3 thousandths removed. You can see that one center exhaust port is still not fully cleaned up. The others are doing quite well. This very end one yet, we're just showing some signs of it picking up here, but that one's gonna beat down more than I originally thought it was. So we'll take another 3 off and see where it is. So I finished machining the manifold surface. I was originally planning on taking only about 10 thousandths off, and all of the ports did clean up at 10 thousandths with the exception of this very last one. I had taken probably between 20 and 25 off. This whole area here was just kind of, probably ran with a bad gasket, and then it was kind of just burned down. There's a little bit of area here that did not clean up, but we still have some solid sealing surface here yet, so it should be just fine. So overall, it came out quite nice, I think. I used really a boring head with a single point tool. It's not really the right setup for using as a fly cutter, but it did work well, so I'm happy with the finish. I was looking at the top of the head here where the valve cover mounts. I decided to machine that flat again, although it is pretty flat, and it doesn't really need it. There is some pitting. I believe a thermostat housing mounts here. There's a little pitting there. There's just a block off plate here, a little pitting there. Like I said, it doesn't really need it, but being that I machined the head gasket surface here and the manifold surface, I might as well just go ahead and do that. See what that looks like as well. The head is mounted to the table. I've put red dye on to see what cleans up. I did do some checking. The high spot of the head right now is currently about in the middle, so that's where I'm expecting it to touch off. So I did touch the tool off there. I just plan on taking a few thousandths and making a pass to verify what cleans up and how much more I may need to take. And I have just a single point carbide cutter in it, and it's pretty much maxed out to what you can cut with it, but I've got it's cutting a little over an 8-inch width for the pass, so here we go. So here's our first pass. You can see it did hit a little higher in the center first. Also did hit in this corner a little bit. Here we can see where the thermostat housing mounts here, how it is dipped down here just a little bit. Now it's probably only very little, maybe a couple of thousandths, and it is pitted up on this side just a little bit. So this should help seal. Okay, so here's the end result of machining the valve cover side of the head. We took about 6 or 7 thousandths off. It pretty well cleaned up. There's a little bit of distortion here around the thermostat housing opening in the head, but it's quite good. So as a final check, I set the head on the granite surface plate. I'm running the indicator around and it droops off maybe a thousandths or thousandths and a half on the very ends of the head. And that's kind of to be expected because I'm running to the extreme travels on the machine in both directions. So I could not find any tolerance on what that should be, but I believe that would be well within an acceptable tolerance if it droops off just a little bit on the ends. And this here is not sealing this head gasket, it's sealing the valve cover gasket. So I milled the other side of the head in the other machine last year, and I actually got that even closer yet, so it's about within a thousandths or maybe a little less. We're going to end the video here. Thank you very much for watching. Please subscribe. It doesn't cost you anything. Just hit the subscribe button. It helps out the channel.